at a problem from 6.5. I was actually going to start from maybe 6.2, 6.3, maybe a little bit of 6.4, but I usually, when it comes to 6.4, I usually remove a bunch of problems just because they're just not that important, to be honest with you. But on 6.5, let's take a look at 6.5. Let's see if it's similar to yours. It could be maybe different numbers, or it could be the same. So it says the capacity of an elevator is 10 people or 1,600 pounds. The capacity will be exceeded. Let's see. The capacity will be exceeded if 10 people have weights with a mean greater than 160 pounds. So suppose the people have weights that are normally distributed with a mean of 169 pounds and a standard deviation of 30 pounds. So the first question is, find the probability that if a person is randomly selected, his weight will be greater than 160 pounds. All right. So what I'm going to do, because they're asking for just one person, this is a normal CDF kind of problem. So let's try to describe the situation using our notes. Okay, gotta get warmed up. It's been a while. So we're given that the mean of these weights is 169 and the deviation is 30. So what does that really look like? It looks like this. It means that right in the middle, the mean is 169, and it also means that the standard deviation is 30. So if I add 30 and subtract 30, this is a range of weights. We already know this is about 70% of people will weigh between 139 and 199, approximately. Now, they said find the probability that if a person is randomly selected, his weight will be greater than 160. Well, that means we're going from 160, which is a little bit, from 160 on up is 50%. And this is also 50% lower. So 160, if I had to take a wild guess, I know that it's a little bit more than 50%. I'd have to say about, I probably would guess about 52, 53%. But we're going to find out exactly how much, because this line represents 160. I don't have enough room down here, so I'll put it up here. And I'm going to highlight the region that I'm trying to find. I need to find this portion of my normal curve. Now, the whole curve is 100%. Half of the curve is 50. So that's why I said this is a little bit more than 50%. Now the question is how do we know to find it? How do we know for sure? So what we're going to do is use the calculator. Here's my calculator, and the model that I'm using, I'm going to use the TI-84 Plus model, so that, well, they're all the same. And I'm going to find normal CDF is under second distribute. Very pixelated. This looks a little choppy, but it's okay. Normal CDF is number 2, so you can go down and hit enter. And it looks like I have on Stat Wizard. So it's asking me for my lower bounds and my upper bound. Well, my lower bound is 160. My upper bound, there is no upper bound, so I have to just put in a very large number. And I'll put in like a very large number. And those are my two bounds. So I could find the area of any region. All I need is the two bounds. So getting back on my calculator, where'd that go? My lower bound is 160. My upper bound, I'm going to put in 1 billion. That's 1 e to the 9. That's kind of overkill. Actually, 1,000 would have done it. 10,000. Yeah, it definitely would have done it. It's all going to be the same. Now, the mean is 169. And I also have to put in the standard deviation. Now, if you don't have on Stat Wizard, this is what you're going to have to enter in. Now, this is going to paste it to the home screen. Watch this. This is what you would have to enter in if you do not have on Stat Wizard. You would find Normalcdf, and then you put in the 4 arguments. The first is the lower bound, the bound to the left, your upper bound, your bound to the right, and because there is no upper bound, it's going all the way to the end, just put in a very large number. Usually 5,000 or more would be more than enough. We'll get the same approximation, but sometimes we put in even more than that. And then Normalcdf will accept the mean and also the deviation. Now hit enter, and it says 0.6179. So it would be, the probability is therefore 0.6179. That's 4 places. We got it. B, find the probability that 10 randomly selected people have a mean that is greater than 160 pounds. So this is where, and so I don't want to get too deep on this. And I'm going to also look at, I got to see some other questions for you guys, so hang tight. Okay, I see Jessica and a few others. I'm going to answer those questions. But let me get to this. In order to actually solve this kind of problem, we would need a brand new sampling distribution. The Normalcdf doesn't work for this one. What we would need is a sampling distribution of sample size 10. But guess what? We don't got to go through all that because we know, and I'm going to show you here. Let me pull this up. We need a new sampling distribution of sampling size 10. So in other words, get a sample size of 10, calculate the mean, get another sample size of 10, calculate the mean, get another sample size of 10, calculate the mean. Guess what? The mean will still be the same as the population mean. Still 169. But the standard deviation will be different, smaller. The standard deviation will be 30 divided by the square root of the sample size. So, if I needed to find the proportion of people from 160 I can pretty much, I'll highlight this region. I can pretty much do it the same way. The only difference is the deviation will not be 30. The deviation will be 30 divided by the square root of 10. And so this is what you will do. I'm going to do a second entry. Keep everything the same, but I'm going to modify my deviation. It's going to be divided by the square root of 10. Close bracket. Everything else is the same. 0.8286. And this is where we pray, hope that we get it right. And there it is. Now the question is does the elevator appear to have the correct weight limit? Why or why not? Well, we just saw that according to this, 82% it will be at capacity. So this is pretty dangerous. The other, what is that, 18, 17% of the time, the elevator will be filled over capacity. So all it takes for the elevator to be at capacity is 10 people who weigh 160 or more. The chance of that happening is extremely great. The probability that there'll be 10 people with a mean weight, the average of everybody's weight greater than 160 is 80 to 86 according to the mean and deviation. So does the elevator appear to have the correct weight limit? Why or why not? I don't think it does. And here it is because there is a good chance that 10 randomly selected people will exceed the elevator capacity. And there's an 82% chance, that's more than 50%, and that's more than betting odds. Let's see if this is, matches the correct answer. It does. And I don't think there's no more parts to this. Um, I'm gonna jump to 6-4. Let's jump to 6-4. It seems like there's some questions on 6-4, and then you could also send me questions if you don't have access to type in YouTube. You can also message me questions, and I can go to those as well. I see Bridget has mentioned something, and a few others on 6-4. So let's get to 6-4. I think 6-4 is where a lot of the questions lie. If the problem is just insanely hard, I'll probably just remove it. I don't want you to spend more than 2 hours on this assignment, all right? Or especially more than an hour on one single problem. I do not. That's unless, of course, you're really studying it and trying to understand it. But I think let's get to problem number. Let's look at question number 3. All right. Assume a population of 2, 4, and 12. So that's my population, just 2, 4, and 12. Assume that samples of size n2 are randomly selected with replacement from the population. Listed below are the 9 different samples. Complete parts A through D. All right. So the first question is find the value of the population standard deviation. And I'm going to use my calculator to get the deviation. And hold on, Diego. After I'm done with this, I can try to answer your question. But let me finish this one. This is from 6-4, and I'm going to first find the deviation of the population. The population only has 3 values in it: 2, 4, and 12. And so let's pull up that calculator. And in order to get the population deviation, you do have to enter the data in a list. So the population is 2, 4, and 12. Now, I do have to alert you on something. There's 2 different types of populations, okay? There's the sample population, and then there's the there's the sample deviation and then there's the population deviation. So if I go in the second list and go over to calc, at the bottom, number 7, this is not the population deviation that it gives me. This gives me the sample deviation. This is not the right answer. It's assuming that the data is a sample. So in order to get the population deviation, I have to do one var stats. So I go into stat and go over to calc. One var stats, choose L1, and little sigma x is the population deviation, 4.32. And they want me to round it to 3 places. So 4.320. You can drop to 0. It's not significant. Here's the next question. Find the deviation of each of the 9 samples. Then summarize the sampling distribution of the standard deviations in the format of a table representing the probability distribution. It seems like you guys have already done this. And we're eventually going to compare, does the population deviation target the sampling distribution? And the truth is sometimes it does and sometimes it doesn't, because this is a standard deviation. All right. Now, how do we calculate the deviation of these little samples? Well, again, we could go back into the lists, edit, enter in a list like 2 and 4, for example. And because that's a sample now, I can actually use, I can go over here, I could use, I can go to math and standard deviation, number 7, and then use L1. 1.4142. Or I could also, let me show you the other way. You can go into stat and then go to calc, one var stats, L1, and I get it. Sx is the sample sample deviation, standard deviation. So 1.41. So I got 1.41 when I did 2 and 4, and also 4 and 2. Also, look, 2, 2, 4, 4, 12, 12. That deviation will be 0. So let me just, let's see if I can try to copy this. So deviation here, I'll put 0 here, 1.41, 4, 2. 212 I didn't do yet. 4, 2 is the same as 2, 4. 4, 4 will be 0. What else? And this one will be 0. The standard deviation. I have to find the standard deviation of all of them. 2 and 12 is next. Let's see if I can get the standard deviation of 2 and 12. .071. And that's the same as 12.2. And now I got to do 4, 12, and 12, 4. So I'm just simply finding the deviation of all my little tiny samples. This is like microstats. There's no real application for this. They just want you to do this so that you can understand that there are different types of distributions. So we're going to look at the standard deviation sampling distribution. That's what this is going to be called. That's what it's forming, a little deviation. A probability distribution as well. So let's do 4 and 12 now. So I'm going to go back into my list and edit my list to have 4 and 12. And now I'm going to calculate one of our stats on L1. Second entry will just recall the statement. And I got 5.6568. Or 5. I'll just say 5.657, and over here 5.657 there. All right. Now, what do they want me to do from here? Once I've found the standard deviation of everyone, I need to simply calculate the probability of getting each one. Like, what's the probability of getting a 0? And there's 9 of them. There's 3 zeros out of 9. So the probability of getting 0 is 3 over 9, which reduces to 1/3. Now my next value is 1.41. There's 2 of them. So let me find 1.14, 1.41. There's 2 out of the 9, so I'll do 2 ninths. Let's look at another one. 5.65, and there's 2 of those. And the last one that I had, 7.071, and there was 2 of those. All right. So that looks like I've done what I had to do. I'm going to check it. It said nice work. And the question is, find the mean of the sampling distribution. So they want me to take the average of this. They want me, and we're just going to follow the directions. Find the mean of the sampling distribution of the sample standard deviations. So they want me to add them all up and divide by 4. Well, if I add it up, it's going to be 1. Let's get this right. Hold on. The mean of the sampling distributions of the sample standard deviation is what? So they're talking about not the probability, but the mean of the sample deviations. So I'm going to add up these guys, and I'll divide it by 4. There's really 2 ways to do this, because the truth is there's really 3 of these guys. There's really 2 of these. There's 2 of these and 2 of these. So when they say calculate the mean of them all, they probably want us. There's 2 ways to approach this. Okay, they probably want us to add up all of these, and then we would divide by 9. That's one way to do it. Or they might just mean, hey, take these 4 and divide it by 4. So there's 2 ways to do it, but I'm actually going to do it the long way because that's probably the way they wanted it. So there's basically 3 zeros. So when you add those, that's just 3. And then I'm going to do this one times 2. So 1.414 times 2 plus 5.657 times 2 plus 7.071 times 2. There's 2 of them. We're adding them all up. And now we're going to divide by 9. Because there's 9 numbers all together. 3 zeros, 2 of these, 2 of these, and 2 of those. We added them all up as fast as we could. Now we're going to divide by 9. This is how you calculate the mean. And I got 3.14. That looks like close to pi. 3.14. And let's see if that works. They want us to round it to 3 places. So 3.143. Okay. And now the question is does it match? Does it target like is 3.14 4.32? And the truth is it's not targeting that really, because if it was targeting it, it'd be very, very close to it. Now they are similar, they're kind of in the ballpark, but they're not exactly right. And they're not going to target it for a lot of different reasons. And one of the reasons is because the conditions haven't been met. There are certain conditions that have to happen. So you just choose one of these. Do the sample standard deviations target the value of the population deviation? In general, do sample standard deviations make good estimators of population standard deviations? So I'm leaning towards B. The sample standard deviations do not target the population standard deviation. Therefore, sample standard deviations are biased estimators. So let's choose B. And it agreed with us on that. That was good. Any questions on 6.4? Are there any others that I did a good job on 6.4 in the video? Remember, I did the fruit fry problem. I even got stuck on it and eventually got the answer right. I did the fruit fry problem. I don't know if it's even there. Probably took it out, or maybe it's there. Oh, there it is. But it's different. I got 1 male this time and 3 females. A, B, C, and D. The proportion of males and samples of 2. But because you're doing replacement, you can get the same fruit fly twice in your sample. So we figured out that their sample space will be 16 different numbers. 6.5 is not that confusing, guys. All right, we can move to 6.5 if you like. Let's go back to 6.5. Are there any questions on 6.5? I see we have a few viewers watching right now. So if you have questions on 6.5, I'd like to get to some of those questions from 6.5. I think in the chat we did have a few. Someone was stuck on trying to find some questions from 6.5. Basically, all you're doing is you just do normal CDF, but when it comes to the sampling distribution, you're going to divide by you're going to divide the deviation by the square root of the sample size. Problems 6, 7, and 8. Let's do it. Women's have head circumferences that are normally distributed, the mean of 23.68 and a standard deviation of 0.7. If a hat company produces women's hats so that they fit the head circumference between 23.5 and 24.5, what is the probability that a randomly selected woman will be able to fit into one of these hats? So the first thing, I'm going to show you exactly what you do for this one. For part A, it's just normal CDF. Okay, watch me do this one. Just normal CDF. What's my lower bound? 23.5. What's my upper bound? 24.5. What's my mean? 23.68. My standard deviation is 0.7. And this is the proportion of women whose head circumference is between those lower bound and upper bound measurements. So the probability that if I randomly select a woman, and if I round this to 4 places, it's going to be 48.08. Now, here comes the confusing part. That's a joke. It's not confusing. Actually, this is different. This says if the company wants to produce hats to fit all women, except for those with the smallest 1.25% and the largest 1.25% head, what head circumference should be accommodated? So for the minimum, this is a great problem. This problem should be on the quiz. I like this problem. I think it's a good problem. Let's make our distribution. And remember, my sample mean is 23.68. My little deviation guy is 0.7. And actually, it should be this. It's the population of all women. We're talking about the population. So now, what about if I needed to figure out an X value and this represents 1.25%. Tiny, tiny region. Here's another one. And another one. Over here, hold on. I'll call this X min. I'll call this X max. So what is this value that's going to give me the lowest 1.25%? So what we're going to do is use inverse norm, IMV, of this area. You have to convert this to a decimal, 0.0125. The mean and the deviation, 0.7. Let's do it. Go to second, distribute, number 3, The area is 0.0125. The mean is 23.6. And 0.7. And I get 22.03 for my minimum. So if your head is 23.03, you are in the lowest 1.25 percentile. The bottom 1.25%. Let's test that out. 23.3. And let's check the maximum. So the problem is that inverse norm only works when you have the area to the left. But the problem gives us the area to the right. So what would be the area to the left? If the area to the right is 1.25, what is the area of the remaining piece? So one way to figure that out is to actually just do 100% minus the 1.25%. And that puts us at 98.75%. So X max, this region represents 98.75%. This little piece is the other 1.25%. So I'm going to use 98.75 for my inverse norm. Here we go. I could just do a second recall. Second entry, and I'm going to put in 98.75. And I got 25.17. And the other one was actually the other one was 22.03, so I mistyped that. So we got 22.03 and 25.17. Let me double check my formulas. It says round. I did round. $23.6 for the mean. It's actually 23.68. Okay. Actually makes a big difference because so 25.25 when you round to the nearest hundred. 25.25. I also have to check the other one too, because maybe I didn't use the other one as well. So I'll recall the other one. So this guy, and it's 23.68. That was a big mistake. Second insert 8, and then just enter. 22.11. Now here's where this is now part C is a 6.5 problem. It says if 18 women are randomly selected, that's a sampling group. We need a whole new distribution. We can't use the normal distribution. That normal distribution was for women, one woman. Randomly selected women. Now we're talking a group of 18 women. So what we need is a random sampling distribution of 18 women. Okay? And let me explain how it works, just so that you can be clear on this. Remember, and let's go back to this real quick. This is all women. I don't know how accurate these numbers are. So that's mu, the population mean, and this is the population deviation for women. So that's just like, hey, if I measure every woman ever on the planet, and I calculate the mean. I know it's practically impossible to actually um, to know the population mean. That's why we work with samples and then we estimate the mean. But let's just say, for the sake of argument, we've done it. We figured out that the population mean around their head, their circumference of their head, is 23.68. And then we calculated the deviation, the spread of how far the numbers fall from the mean, is 0.7. So it varies, but majority of women is going to be near the average, 23.68. But now they're talking, now what they said to us is, they said, hey, what about 18 women? We can't use this sampling distribution is for women. So for 18 women, what we have to do is we look at the population of women, and then we choose a sample of 18 and another 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 sample of 18. We choose sampling and then we calculate the mean of each one. We calculate the mean of our sampling distribution. And some of these can overlap because we're replacing them back in. So once we do 18, we put all the women back, all 18 women back, and get another random group of 18, calculate the mean. We get another, we do every possible combination. This is a lot, all right? But guess what? It turns out the sampling distribution of means is equal to the population mean. So the sampling distribution, it's different, but there is something that's the same. The mean is the same. But the deviation is not the same. The deviation will actually be 0.7 divided by the square root of 18. So it's going to be a little bit more narrow. But now I can answer the question, and the question is, let's go to the problem. If 18 women are randomly selected, what is the probability that their mean head circumference is 23.5 and 24.5? If this probability is high, does it suggest that an order of 18 hats will very likely fit each of 18 randomly selected women? So basically, you're just interpreting the answer that you get. So what I need to do is, it's the same lower bound and upper bound as before. So I'm going to go into second distribute, normal CDF. My lower bound is 23.5. My upper bound is 24.5. The mean is 23.68. But the standard deviation is not just 0.7 anymore. It's 0.7 divided by the square root. You could just put it all in here like this, like the way I'm doing it here. 18. Now we're going to paste this onto the home screen. Make sure that was 18. Yep. Enter. And our probability is a little higher now. 8624. So 0.8624. And now we just interpret that question. This probability is really high. This is good. If this probability is high, does it suggest that an order of 18 hats will very likely fit each of the 18 randomly selected women? Well, there's an 86% chance that it will, but there is a 13.79% chance that it will not fit. So A is, you can't really refute A. I mean, what they're saying in A is actually pretty accurate. Yes, the probability that it, no, the hats must fit individual, not the mean for 18 women. If all the hats are made to fit head circumference between, it won't fit about half. I wouldn't say half, but well, that's actually the answer in this part. So the probability of one single randomly selected woman is going to be 0.48, so almost half. C is actually good too. C is a nice choice too. And then D, yes, the order of 18 hats will very likely fit each of 18 randomly selected women because 23.5 and 24.5 lie inside the range found in B. And here's the thing. When it says the hats won't fit about 13.70%, that's 13.70% of the mean group. So for that reason, I'm going to go with C. C just seems like a solid choice. When we talk about individual women, it's true about half of them, it will not fit between this range because we found the probability of that. Let's check, and we're right. C is good. You haven't taken the quiz yet? All right, there's a question about the quiz. Was that question on the quiz? You got to take that quiz, man. The quiz is due tonight. Um, so let me back out of there. Hold on. Here we go. Here we go. Um, is it tonight? Yeah. Uh-oh. This, oh my God. This one looks so scary. I'm just gonna randomly choose some stuff. Just so I can see some more. Uh-oh. What are they talking about here? Up, there's another one talking about pregnancies. 85 percentile, 5% percentile. It's hard to say. Keep in mind what this means. In fact, the answer to this is probably even on the table. Below 1%. 2.57. I'm going to exit that out. If there are no other questions, guys, we're going to wrap up this video here. I will make another one on chapter 8 and 9. There was a request for that, but I'll probably do that later during the week, maybe Thursday or Friday. All right, so work together, guys. Hang in there. Get that quiz done, you know, and just, you get multiple tries at it, so it's okay to take it one time and screw up on it. It's totally okay, just to get a feel for it and to realize how much more you got to study and what you know already. They do look like some of the homework problems, so make sure that you understand those homework problems and that you can review those and you know how you got those worked out, so you can get that quiz done. All right. So thanks for watching, guys. I mean, I think this was helpful. I think this was very useful. I feel connected to you guys. I've been getting a lot of messages. I try to respond as soon as I can. So keep messaging me, and I'll keep responding. And we got to finish this course very strong. Okay. I may take out. Well, I'm gonna post the. There's 15 questions on the final. And what I'll do is I'm going to post the sections that those questions come from. Um, so that like there might not be a question from 7.3 or there might not be a question from 9.2. I think that would be very advantageous, um, to have that sort of information. Um, there was a request to do number 4, and is that from 6.5 or from 6.4? Maybe 6.5 or 6.4 from number 4. I already know the sample median will not target the population median. When is the due date on the final? It is the Friday the 21st. It's the final due date. But it opens the 19th. And the practice is open now, by the way. And I can do the practice. We can do that as well. I can make a video on going over the solutions to the practice final. Just remind me in a couple, maybe early next week. But yeah, just stay focused, get this out of the way, and get ready to finish up strong. All right, because chapter 7 and 8, you don't want to get burnt out with chapter 6. You want to jump into 7 and 8, and spend some time on 7 and 8. 9 not so much, but 7 and 8. 8's a biggie. 10, you know, 10-2 is pretty easy. Let's take a look at one more problem. Let's look at question number 4 from 6.5. So I'm going to just do this quick for you. It says if one woman is randomly selected, find the probability that their height is between 64.3 and 65.3. So all I'm going to do, I have the mean of all the women, their height, mean height, and their standard deviation of all the women. So now all I got to do is do normal CDF. I do their lower bound, 64 mean. Do the upper bound, 65.3. Then the mean, 64.7. And then the standard deviation is 2.5. Okay, so this is a 6.3 kind of question. This is the kind of questions that you had to do in section 6.3. You hit enter, you get 0.1584. And now if 7 women are randomly selected, find the probability that their mean height is between 64.3 and 65.3. So I have to use a sampling distribution of 7 women. So I'm just going to do the second entry, and instead of the deviation 2.5, I have to divide it by the square root of 7. It's the same thing. I'm just dividing by the, it has a different deviation. 0.4012. And that's that. I hope you caught that. I did it pretty fast, but the main thing I wanted you to see is that the sample deviation changed. It's 2.5, but you're dividing by the square root of that sample size. All right, guys, we're going to wrap it up here. I'm going to post this link so that others can watch this. Hopefully it's still available. I don't know, they changed the settings. All right, you guys have enjoy the rest of your evening. Get to that test, that quiz if you haven't done it yet, and I'll be back in touch soon.